This is Unit 2, the first lesson of it, Trigonometry Review. Most of the things you see today should be reviewed from grade 11 or grade 10. We'll be looking at right angle triangles today, in particular the Sokotoa rule and how we can use that to solve parts of a right angle triangle that we don't know. Just a quick reminder at the beginning here, 3 sides to a triangle. Hypotenuse, we've been talking about a lot as the idea of Pythagoras. It's across a right angle. The other 2 sides are labeled according to an angle that you're given. So on the first page here, this first example, if my angle theta down here in the bottom right corner is given, the angle across from that would be the opposite, and the side beside that would be the adjacent. Okay? If the angle moves, the opposite and the adjacent will move accordingly. So just keep that in mind. Some things to remember about solving these kind of problems: you're either going to be using cross multiplying if the unknown is in the fraction, or you're going to be using an inverse, sine -1, cos -1, tan -1 of whatever ratio you have. And we'll go through those 3 examples when we get to them. There really are only 3 kinds of questions you can solve with Sokotoa. We'll do them here, A, B, and C. When I say 3 questions, I don't mean sine, cos, and tan. I just mean 3 different spots where you can put the x. First thing you want to do when you're solving a right angle triangle is label your sides. You really only want to label 2 of them. That will tell you which ratio you're going to use. So if I'm given the angle 72 down here in the bottom right corner, the angle side across from that would be my opposite, and the side across from the right angle would be the hypotenuse. So I have an O and an H, an opposite and a hypotenuse. Remembering that we have a rule called Sokotoa will allow us to decide which ratio to use based on the 2 sides that we have labeled. We really only want to label 2. If we label all 3, it gets a little confusing in terms of what ratio. Looking at this, we have an O and an H, which tells me I should be using the sine ratio. The way it works is the sine of your angle, in this case 72, equals O over H, or in our case, X over 36. That's your O, that's your H. To solve for X, we're going to cross multiply. So we think of there being an imaginary number 1 down here in the bottom. 1 times X, this way will give us X. And 36 times sine 72, we're going to write that out. 36 times the sine of 72. Because X is by itself, we've basically solved this. All we need to do is put in our calculator, making sure our calculators are on degrees. It should have a little D at the top of your calculator, or maybe a DEG. Okay, but either way, when you put that in, you should get 34.24. And that's one of the problems we can solve with Sokotoa, having the X on the top of the fraction. If you look at the second one, again, we're going to label according to our angle. So my angle beside that would be my adjacent. Across from the 90 would be the hypotenuse. I have an A and an H, which suggests to me that I have to use the cos ratio. So the cos of the angle, in this case 40, is A over H. That's the A, that's the H. Again, I have my X in my fraction, so I'm going to cross multiply. Again, think of there being a little 1 down here. 1 times 48 is 48. X times cos 40 is X cos 40. Unfortunately, this time the angle, or the X is not by itself. I still have an X with a cos 40 attached to it. So I need to divide out that cos 40. And they'll cancel each other out, and you'll be left with an X down here. But if you divide one side by cos 40, you got to divide the other side by cos 40. And that's what we're going to put in our calculator. 48 divided by cos 40. And if we do that, we end up with 62.66. That's the second kind of problem we can solve with Sokotoa. X on the top of the fraction, X on the bottom of the fraction. The third kind, only other kind we can do, is to determine an unknown angle. Okay, when we start this off, we start off exactly the same way. Label the sides according to your angle. I see my right angle here, that's my hypotenuse. I see my angle here, beside that would be my adjacent. Oh, A and H. Sokotoa, A and H was cos. So we're going to write down the cos of our angle, don't know what that is this time, equals A over H. Okay, my X is in the third spot. It's not in the fraction, it's the angle this time. So to solve this kind, I'm going to use an inverse function. And the way that's going to look is cos -1 of whatever 12 divided by 24 is. I'm not actually going to divide it. I know I could. It comes up to 0.5. It's easy to work with. But my calculator can do this for me, and why not save myself the step? especially when we get to like a messy number, 12 divided by 17 or something like that. On your calculator, above cos, a second function or a shift function, you should see this cos to the -1 thing. And when you put that in your calculator in the right order, you get 60 degrees. Okay, and those are basically the three questions we can do with SOHCAHTOA. Yes, there are word problems, yes, there are more complicated things, but everything reduces down to one of these three questions. Just before we get to some of those more complicated word type problems, some ideas here. Elevation and depression are words that come up often when we're doing SOHCAHTOA questions. The elevation of the sun, you have to look up at the sun. Or you're standing on top of a cliff and you're looking down at something. That would be an angle of depression. The trick here is you're always talking about the angle from the horizontal. The horizontal would be what happens if you look straight. If you go up from there, that would be elevating your view, and you'd talk about this angle. If you're looking down from there, you would be talking about down from the horizontal. That would be your depression angle. Okay, always from the horizontal. So you have to be a little bit careful. One nice thing about these two angles, if you actually draw them out, depression and elevation turn up to the same angle by following the Z pattern. Okay, that should take you through the first 2 pages actually of SOHCAHTOA and